Hi, I Aniket Kanade welcome you to CKAD MasterClass for learning Kubernetes. In our prerequisite session, we looked at what Kubernetes is and why do we need a container orchestrator like Kubernetes. In this session, we are going to look at the components of Kubernetes and how to install Kubernetes. So let's begin. So this is our agenda for this session. First, we are going to look at Kubernetes components and their roles, how those components interact with each other, how together they achieve the goal of container orchestration. Then we will look at Kubernetes installation the hard way. Kubernetes installation using Kubeadm tool and a demo of Kubernetes installation using Kubeadm tool. Well, before we begin further discussion on Kubernetes, I wanted to introduce the concept of Kubernetes components and Kubernetes objects. Kubernetes components. When we say Kubernetes components, we mean the internal design elements of Kubernetes. These are several modules that make up the entire Kubernetes. Whereas when we say Kubernetes objects, we mean different configurable entities that Kubernetes operates on to achieve container orchestration. Example of Kubernetes components is Kubernetes scheduler, Kubernetes controller manager, DNS, etc. Whereas the example of Kubernetes objects is pods, replica set, deployments, services, etc. Kubernetes components can be seen as what makes up Kubernetes, and Kubernetes objects can be seen as functional elements or what Kubernetes operates on. To understand Kubernetes components or Kubernetes internals, we are going to use ground up approach. We are going to start with clean slate and build Kubernetes on top of it. First, to run our application containers, we need VMs. They are called worker VMs or data plane. Once we have worker VMs, we need a VM which is separate from them just to run Kubernetes itself. It is called control plane VM or master VM. Once we have control plane and data plane VMs, we need a network that connects all these VMs. These VMs are in different regions and may not be connected by single LAN. Also, we need a network exclusively for Kubernetes to operate on. This network is called Container Network Interface or CNI. Now, once we have the network, we also need an agent on all the VMs that facilitates the communication between the VMs. This agent is called kubelet and it runs on control plane as well as data plane VMs. Along with kubelet, there is also another service called kubeproxy that runs on all VMs. Kubernetes uses several network translations and communication methodologies for internal cluster communication. These network translation and communication rules are handled by kubeproxy. Now, each worker VM needs a container runtime. Kubernetes operates on several container runtimes such as containerd or CRI-O. So container runtime needs to be deployed separately on each worker VM. It is the job of the container runtime to start actual containers, which are called pods in Kubernetes terminology. So we have everything we need to deploy containers on worker VMs. But how are we going to deploy the containers? The rules of container deployments are stored in Kubernetes configuration. There is an element or a component in Kubernetes called Kubernetes scheduler. The job of Kubernetes scheduler is to decide which worker VM would run which container or pod. Hence the name Kubernetes scheduler. Now once scheduler decides which container runs on which VM, and once containers are started on those VMs, we need a component or an agent to monitor the state of those containers. And not just the state of the containers, but we need an agent to generally monitor the actual state of the cluster as against the state desired or configured in Kubernetes. It is the job of Kubernetes controller manager to constantly monitor the cluster and correct the abnormalities or anomalies when the desired state is different than actual state. One simple example is replicas of a container. If a container or pod is configured to run 5 replicas, and for some reason only 4 replicas are running, it is the job of controller manager to start the 5th replica and achieve the desired state. Controller manager would keep monitoring the number of replicas until the desired state is achieved. Then there is also Kubernetes DNS that helps in translation of Kubernetes internal FQDNs to IP addresses. So these elements together, scheduler, controller manager, DNS, kubelet, kubeproxy, would achieve the goal of container orchestration. But we are still missing one key element, the actual cluster configuration. We need a database to store the configuration and an agent that provides API for accessing the database. The database that stores cluster configuration and cluster state is etcd etcd database. And the database access is provided by Kubeadm server. Whenever a new container or a pod needs to be started on a given worker VM, scheduler informs API server about the activity, which in turn sends the information to kubelet on worker VM using a data structure called pod spec. The kubelet on worker VM, upon receiving pod spec, starts the container as per the specification. Then there is also one essential element that is external to the cluster. It's called kubectl. Kubectl is Kubernetes CLI tool that runs on external VM or PC. Kubectl is an operations and administrations tool for human or programmatic users to configure and monitor the cluster. Most of the commands that we are going to use during this course will be executed using kubectl. It is not necessary to run kubectl on an external VM or PC. It can also be executed from master VM, but it is generally a good practice to have a separate administration VM for cluster administration. So to recap, we have control plane and data plane VMs. Control plane VMs run Kubernetes components, whereas data plane VMs run application containers. Data plane VMs host kubelet and kubeproxy, whereas control plane VM or a master VM hosts Kubernetes modules such as scheduler, controller manager, DNS, API server, etcd database, etc. We also have kubectl tool for operations and administration. So coming to installing Kubernetes the hard way. What is Kubernetes installation the hard way? Kubernetes installation the hard way is a tutorial designed and developed by one of the Kubernetes creators, Kelsey Hightower. It's available on Kelsey's GitHub account. The tutorial actually takes you step by step through the process of installing each and every Kubernetes service and configure it to communicate with each other. Kubernetes the hard way is an excellent resource to understand Kubernetes internals and how different components can interact with each other. But I would generally suggest Kubernetes hard way as a later step when you have better understanding of Kubernetes, its architecture, and Kubernetes components. Installing Kubernetes the easy way or Kubeadm way. What is Kubeadm? Kubeadm is a tool which can bootstrap Kubernetes cluster in a single command. Unlike the hard way where you install each and every service, configure it with certificates and everything manually, Kubeadm installs all Kubernetes internal elements like scheduler, controller manager, etc. in a single step. When you execute Kubeadm, it goes out and it pulls all the required images and lays down the cluster as required. Kubernetes official documentation provides detailed steps for Kubeadm based install, and Kubeadm is the most widely used tool for deploying Kubernetes. In our next session, we are going to see the demo of Kubeadm based Kubernetes installation. So now we are going to do a demo of Kubernetes cluster install using Kubeadm tool. The instructions that we are going to follow in this demo are available on my GitHub repository for master VM as well as worker VM. These links along with the other links in this session are available in the description of this video. So here we have two Ubuntu based VMs, Ubuntu 20.04 based VMs that I have set up on Azure. We are going to use one VM as master VM and another VM as worker VM. Also, we are going to follow the instructions from the GitHub page for installation of master VM steps and installation of worker VM steps. So first, let's begin with installing Kubernetes on master VM. Installing Kubernetes in master VM involves following steps. First, we set Kubernetes and OS versions. Then we verify the prerequisites, which is mainly about checking the CPU and RAM requirements and turning the swap off, which doesn't go well with Kubernetes. Cleanup of existing Kubernetes install if any. Download and install required packages by Kubernetes. Set up various config files for Kubernetes. Then roll out the Kubeadm cluster where all the Kubernetes internal modules get installed, and in the end applying the CNI plugin for container network interface. Optionally, we can also configure bash aliases and other things. First is to set up or configure parameters for versions. We are going to install Kubernetes 126.1 version on Ubuntu 20.04, and all this activity is done as super user. So here I have set up the versions. The next step is to verify the prerequisites, which is mainly about CPU and RAM that you have configured for the VM, and then turning the swap off. We have set the swap off. Then we are going to clean up the Kubernetes install if any. Right now this is a plain VM. We have started from scratch, so there is no install right now. You just have to copy paste all the instructions and understand them as you execute them. So we are done with cleanup of Kubernetes install. So now we're going to download and install the packages. We are going to download containerd, which is a runtime, kubelet, which is required for Kubeadm to install the cluster, then Kubeadm itself, and kubectl for Kubernetes administration, and Kubernetes CNI for CNI network plugin. The packages are getting downloaded. And now they're getting installed. So the packages are downloaded and installed now. In the last step, we hold the packages so that they don't get auto upgraded. Once we install the packages, we're going to implement workaround to uninstall the latest container D, which has some problems, and install little older version of the same. So we are starting container D again, and then we are going to configure various config files as root. It that involves container D configuration mostly, and CRI-CTL, which is a utility for container runtime. And after doing that, we restart kubelet. So these are all preparatory steps. Now master VM is ready for Kubeadm cluster install. If we look at, this is the most important command, Kubeadm init, which initializes the cluster. It downloads all the images for scheduler, controller manager, DNS, etcd, etc. It configures them, and it also a rolls out a cluster with one node, master VM, on which it is being installed. As you can see, the cluster is getting installed. The Kube API server, Kube controller manager, Kube scheduler, all of them are getting installed. Your Kubernetes control plane has initialized successfully. Here you see some instructions. These are for kubeconfig file. Kubeconfig file is the file that kubectl utility uses to communicate with API server. Currently, the kubeconfig file is in the root user's home directory. Using these instructions, we can shift the kubeconfig file in the home directory of root user as well as any other user that we want to use for administration. So what we are going to do is we are going to execute these instructions first for root user, and then we can exit so that we go back to the Azure user, which is a non-root user here, and follow the same instructions. So Azure, alright, I think that kubeconfig already exists there. So by copying the kubeconfig file in Azure, we can use Azure as well as root, both users, to communicate with Kubernetes cluster for operations and administration. Towards the end, Kubeadm tool also gives you the command that you can use from worker node to join worker node to the cluster. If we look at the cluster using kubectl command right now, kubectl get nodes, that's the command to check the nodes in the cluster. Yeah, see, there is some errors with it right now. Well, I don't know why it's not working from Azure, but if you look at from root user, if you do Kubernetes get nodes, you see one node in the cluster right now, and that's the master node where we did the cluster rollout. It's in the ready status and it's a control plane node. If you look at the pods using kubectl command, get pods -a is for all, we see the pods that are deployed by Kubeadm tool. Kubeadm tool has already deployed etcd. It has deployed API server, controller manager, proxy, and scheduler. Now we are going to follow similar instructions of cluster setup on worker node. Well, we did not do the optional steps that are needed. That is, we did not apply the plugin yet, so we need to do this on master node, because without CNI plugin the network interfaces cannot work. So now we see that plugin also deployed on master node and we can do get nodes to check. There's one master node in the cluster right now. Now we can go to worker node. Sorry, we forgot to do the optional steps. These steps are to configure bash with certain utility aliases like K for kubectl, C for clear, etc. This is optional. It's up to you whether you want to do it or not. So here we are done with this, and I must make a note that these instructions are taken and based on killer sh GitHub repository for master and worker setup, the reference for which is given here. In the next step, we are going to install a worker VM and we are going to join the worker VM to the cluster. The instructions for worker VM install are in the same GitHub repo. There are similar steps that are needed on worker VM. Preparatory steps are same. We need to set the IDs, then check the prerequisites, clean up the existing install, download and install required packages, set up different config files, and then this is where the things are different for worker node. We need to obtain a token from master node and then join the node as a worker node to the cluster using the token obtained here, and then again configure bash and other aliases. So let's follow the instructions, set up the parameters, disable swap, clean up existing install. We don't have any existing install, but just in case. Download the required packages. We need same packages for worker node as well. We may not need kubectl on worker node, but we are installing it anyway. Normally kubectl is executed either from master nodes or from an admin VM which is outside the cluster. But nevertheless, then again the same workaround. It's required at the moment of this recording. Then we again set up the config files for container deconfiguration, etc. Restart the kubelet, and now this command we're going to execute on master VM to generate the token. when we execute this on master VM, this command actually gives you the command that you're supposed to execute on worker VM to join the cluster. The command that we just have to copy this. Let's copy it and paste it on worker VM, and then we can look at the parameters of the command. Join, then this is the API server IP and port. This is the token that we just obtained, and this is the CA certificate hash that was generated when we executed the command on master. So we execute it, and Kubeadm tool based on these inputs will now deploy the necessary containers and join the cluster on master VM. Here we go. So we don't have to do CNI plugin here. It gets done automatically. And if we run get nodes on master VM, now we see two nodes in the cluster, master VM that we deployed earlier and worker VM that we deployed just now. So that's about installing. Oh, we forgot to do the bash completion stuff. Well, it's we can follow the same from masternode. I don't think we need that here because we don't use worker VM for any kind of administration. We use only master VM for administration. It's up to you if you want to do it, but it's okay if you don't do it. So this completes the Kubernetes cluster install. We installed Kubernetes cluster on a control plane on master node, and we installed or joined one worker node in the cluster that can be used for application workload. So in this session, we went through Kubernetes internals, Kubernetes modules, how different Kubernetes modules interact with each other. We also looked at a couple of ways of installing Kubernetes cluster, and then we did the demo of Kubernetes install using Kubeadm tool. Hope you find this useful, and thank you for watching.